Everybody, welcome to Concept 3.2 lecture video. We're jumping into multipliers. Remember in the last video, and maybe even in class, I don't know, I haven't taught it in class yet, but I'll probably mention it. We said that, yes, Sig-Jigson shifts aggregate demand, right? Consumption, investment, government spending, net exports, all four of those things shift it in the same direction. So if consumption goes up, aggregate demand shifts right, and vice versa, right? We also said that a second thing that we know about every one of these shifts is that it has a multiplied effect. The reason for this is because we're talking about the economy as a whole. Every time a dollar is spent, for example, let's say the government spends money, gives a stimulus check, for example, that dollar becomes income to somebody else. That person will save a portion of the income, spend a portion of the income. The portion that they spend goes back into the economy, is received as income to somebody else, who then will save a portion of that, spend a portion of that, repeat. So if the government puts $1 billion into the economy, it might have a $3 or $4 billion impact in the event that all of every dollar keeps being spent, right? People don't save all of it, they keep spending it. And so we call that the multiplied effect. And we're going to explain that phenomenon using marginal propensity to consume and marginal propensity to save. Here we go. Maybe. There we go. Okay, so let's talk about the multiplier effect. Multiplier effect shows the impact of spending in the economy. So because it's any one of those changes, there's a change in consumption, investment, government spending, net exports, those four will have a multiplied impact on our economy as a whole over the long run, right? It doesn't happen all at once over a long time. So the basic premise of this is that every dollar that is spent is a dollar earned, and then a dollar spent, and then a dollar earned, and then a dollar spent, and then a dollar earned. We call this kind of the velocity of money. Money has a speed at which it is spent, and so it will continue to be spent throughout our economy over time. So let's say John buys $100 or spends $100 at Christine's fruit stand, right? So he likes fruit, gets some fruit. Christine gets that $100. She takes it and goes to a jerky stand, Blake's jerky stand, and she spends $100 on jerky. And then after that, Blake takes that money and he goes to Hank's Hat Emporium and he buys $100 in hats. Notice $100 spent initially buys $300 worth of product when we zoom out to look at just a small portion of the economy, right? The same thing is true for the economy as a whole. A small change in spending will have a multiplied, or we call it a chain income effect over time. But every dollar the government spends, this is important because generally when we're talking about fixing an economy, we're talking about government spending. But every dollar the government spends will have a multiplied impact. This means that we have to be a little cautious with what we spend. We have to be calculated. We can't just pour trillions of dollars into the economy. We want to make sure that we hit our mark. So we want to try to get this right. Okay, so getting it right really gets to understand what the multiplier is, or I should say, in order to get it right, you have to understand what the multiplier is and what the size of that multiplier will be, right? The multiplier, or how much a dollar is multiplied by, that's a multiplier, depends on how much we're willing to spend. If we spend 99 cents of every dollar we receive, then the multiplier is going to be really, really large because only 1 penny is going to be taken out at a time. But if we only spend 10 cents of every dollar received, then the multiplier is going to be really small because in that first transaction, only 10 more cents are going back into the economy. So it really depends on our propensity to spend. So if you spend a lot, the multiplier will be high. If the people of our economy save a lot, the multiplier will be very, very low. In other words, in order for a government spending to be really effective, we want spending to be pretty high. And if we understand that saving is really high, like it often is in a recession, then we'll have to do a whole lot more spending to have the same multiplied impact. So how do we measure this? We measure it using two ideas. It's called the marginal propensity to consume. So there's a group of people, economists mainly, who measure how much we spend versus how much we save of every dollar that comes from our income. So this is an aggregate. So we're looking at all incomes and general propensities or likelihood that you're going to spend it. So the marginal propensity to consume is a percentage of new income. We call it disposable income. It's not money you can dispose, it's just your income after taxes. So, how much of your income people consume rather than save. This is all based on a basic premise that you can only do two things with money when you earn it. You can either spend it or save it. That's it. So, if marginal propensity to consume is 80%, that means marginal propensity to save will be 20%. It's actually a pretty simple equation. We're looking at our change in consumption divided by our change in income. So let me show you this real quick. Get a little pen here. Let's say our change in consumption is $80. We spend $80, but we get $100, right? So our change in income, the delta or the triangle there is a change. Our change in income was $100. I got 100 new dollars. I spent 80 of those dollars. What's my marginal propensity to consume? So it's going to be 80 divided by 100 or 0.8. Now, we know that's 80%, but actually for these marginal propensities, we keep them in decimal form, unlike inflation and unlike the unemployment rate. That's the other thing. We don't have to multiply it by 100. So 0.8 is our marginal propensity to consume, meaning that 80% of all new income in our nation as a whole is likely to be spent rather than saved. If 80% is being spent, how much is being saved? The remainder, 20%. There's nothing else you can do with your money. Let's clear this out and move on. So the other side of it is the marginal propensity to save. This is a percentage of all new income that comes in that we are likely to save rather than consume. So it's MPS, or marginal propensity to save, your likelihood to save of all new dollars that come in. So again, let's say that you get $100, similar income, but it's just change in savings over change in income. So let's say, let me go back, got the wrong thing picked. Let's say that your income goes up by $1,000. Congratulations, you made $1,000, and you decide that you're going to save 500 of those dollars. So that's your change in saving. So if I'm going to save 500 of my $1,000, my marginal propensity to consume is going to be 500 divided by 1,000, or 0.5. In other words, I'm going to save 50% of all the money that I earn, right? This means I'm pretty conservative. I'm pretty concerned about the economy generally if this is what's going on. If I'm saving 50% of my money, how much am I spending? 50%, right? You can only do two things, spend or save. So if I'm saving 50%, then I'm spending the other 50%. In other words, if MPS is 0.5, then MPC is 0.5. Okay? So a general equation that will serve you well is MPC plus MPS will always, always, always equal 1. Or the percentage of MPC and the percentage of MPS will always equal 100%, because you can only spend or save. So these two ideas will always equal 100%. So if MPC is 0.75, MPS is 0.25. If MPC is 0.9, MPS is 0.1. And this will come in handy as a little shortcut for you, because we use MPC and MPS to multiply. Remember earlier we said if you save more, the multiplier will be lower. If you spend more, the multiplier will be higher. Well, we use that concept to be able to calculate a number which indicates the multiplied effect of every dollar spent in our economy. Here's how it works. We call this the chain income effect. I referred to it earlier. Let's say $100 comes in, right? New income. But $100 comes in and our MPC is 0.5. Then for that new $100, $50 of it is consumed. We use it on consumption. That means going into round two, $50 are actually going to become somebody else's income in round two. I spent that money like at the jerky stand, right? $50 comes in as income. Now in round two, that person has that $50 in new income. They save $25. They spend $25 because their MPC is 0.4, or 50%. So $25 actually spent. Remember, a dollar spent is a dollar earned, so that money comes in as income. 25 new dollars go into round three, and $12.50 of that is going to be consumed, and $12.50 is going to be saved, and on it goes. See, this is going down until we are at zero. In other words, we will continue this all the way until all of those initial $100 are down to $0 because we save the money or we leak the money out of it. So $100 on the front end can have an incredible multiplied impact. Of course, in this case, it'll have a $200 impact for $100 in new incomes. And I'll show you how to get that in a second. Now, the good news is you don't actually have to use this process. This just shows you the concept. There's actually a quick shortcut to find the spending multiplier, and it looks like this. Spending multiplier is 1 over MPS, right? Or 1 over 1 minus MPC. That's the same thing, right? Remember, MPC plus MPS is 1. So 1 minus MPC is MPS. So sometimes they'll give you MPC and you'll have to calculate the multiplier. You just have to find MPS first in order to find that. Okay? The 1 over MPS will give us a number that is our multiplier. So what this equation does is it actually takes all of those rounds of the chain income effect and puts it into one very simple equation for us. And so I can simply plug numbers in. I can say, hey, MPS is, go back, MPS is 0.2. Well, 1 over 0.2 equals 5. So my spending multiplier is 5. In other words, for every dollar I spend, it's going to have a multiplied impact of $5. Okay? Or I can say, I can make this a little more complicated on you. I can say MPC is 0.75. If MPC is 0.75, what's MPS? Well, it must be 1 minus 0.75 or 0.25. Remember, 0.75 means 75% of all new money coming in, I'm spending, which means 25% of it I'm saving, or marginal propensity to save. So MPS is 0.25. 1 divided by 0.25 equals 4. In other words, for every dollar I spend, it's going to have a multiplied impact of $4. So if I want to have a $4 impact, I only have to spend $1. That's the concept here. It helps us understand how to fix the economy. If I have a $100 billion impact, then I'm going to have to inject $25 billion of government spending into the economy. Because that $25 billion will have an impact of 4, which means that it will equal $100 billion at the end of the long run. Okay? So that's the simple equation. You got to know this equation. Now, friends, that takes time. Plugging that number in, you normally have to pull out your calculator. 1 over 0.5 equals 2 or whatever. I highly, highly, highly recommend memorizing this short chart. You could plug those numbers in, memorize the equation, but you might as well spend a little bit more brain juice and memorize this chart because these are the most common multipliers. Almost every single time you see it, you will have one of these multipliers as a result. So if MPS is 0.5, the multiplier is 2. 1 over 0.5 is 2. If MPS is 0.1, the multiplier is 10. 1 over 0.1 is 10. If MPS is 0.2, the multiplier is 5. 1 over 0.2 is 5. And if the MPS is 0.25, the multiplier is 4. 1 over 0.25 is 4. Because you're not allowed to use a calculator on the actual macroeconomics exam, they believe that these equations actually make it easy for you to calculate in your head or on paper. So 1 over 0.5 is actually 1 over 1/2. That's what kicks out 2. 1 over 0.1 is actually 1 over 1/10. That's what kicks out 10. And 1 over 0.2 is 1 over 1/5. And that's what kicks out 5. And of course, 1 over 1/4. And that's what kicks out 4. So in their view, division of fractions is easy enough to require you to not use a calculator. You might be good at that. I'm not. So I just memorize the chart. I know 0.5 is 2. And that gives you a quick shortcut because normally that's not the final answer. It's not what they care about. They care about the final impact, not the multiplier. So it gives you a little shortcut to figure out the multiplied effect, and then you can plug the numbers in. Okay, let's keep going. So how does this impact our economy? Well, remember we said normally when we fall in a recession, the government has to step in and fix it. We'll talk about this later. We call it fiscal policy. We're seeing it right now in our economy. So what happens is you have an initial change in government spending. That change is going to go into the economy. It's going to become income to somebody. They're going to save a portion, spend a portion. That spent portion is going to become income to somebody else. Repeat the chain income effect. That chain income effect is all built into our multiplier. So it's simply our initial change in spending times our multiplier will tell us the change in GDP this will have in the long run. So if the spending multiplier is 2 and the government spends $100 billion, what impact is that going to have? Well, let me pick a color here. Okay. Well, if my multiplier is 2, then my MPS must have been 0.5. Over 0.5 equals 2. My change in spending is $100 billion. Well, I take that 100 billion times 2, and that gives me a change in change of $200 billion. Okay? Not so bad. Now, in the event, notice that government spending has a multiplied impact because people get that money and they spend it and it becomes somebody else's money. So we have to take that into account because we don't want to overshoot it and cause hyperinflation, aggregate demand shifting way to the right, causing demand pull inflation. We don't want that to happen. Okay, so we have to be strategic in this. Calculating the multiplier helps us with that. Now, what if you have a recessionary gap of $400 billion? In other words, we're in a recession, and to get out of the recession, we have to have an increase of spending of $400 billion. The way I do this is I know I want my total change in GDP to be $400 billion. I know my multiplier is 2. So what spending has to happen to have an impact of $400 billion? I have to have an increase in government spending of $200 billion to have that impact. Okay, this is generally how we use this in AP economics, AP macroeconomics, right? We see the gap, we say the gap is this large, here's our multiplier. How much of a change in government spending needs to happen to close this gap? I hope it makes sense. Again, we'll practice this tomorrow. What about taxes? Taxes are a little bit different. For taxes, the multiplier is not as large, right? Later on, we'll talk about another mechanism. We have government spending is one mechanism to impact the economy. A change in taxes is another. But when we change taxes to have a positive impact on the economy, the multiplier is actually diminished a little bit, right? There's a reason for this. When the government spends money, all of the money immediately gets injected into the economy. But when I cut taxes, that just shows up in people's paychecks, right? And when it shows up in people's paychecks, it wasn't initially spent. When it shows up in my paycheck, I'll immediately save a portion of it before it goes into the economy. If the government's like, I don't know, buying a battleship, that spending happens, all of that spending happens. The $1 billion for that battleship happens at the same time. But if they cut taxes by $1 billion, there's never the spending on the battleship. That just shows up in our checks, and we're going to save a portion of that billion right away. So it diminishes the impact of it. For example, if MPC is 0.75 and we have a $4 billion decrease in taxes, what's going to happen? Well, how much of that am I going to save? Well, we know I'm going to spend 0.75 or 75% of it. 3/4 of 4 is 3. So I'm only going to spend 3 billion. I'm going to save 1 billion of those taxes, which means 1 billion saved, 3 billion spent. The impact of our economy is immediately diminished. Even though we decreased taxes by 4 billion, only 3 billion went into the economy. I take that 3 billion, I multiply it by my multiplier, my spending multiplier, and that's my impact. Now, if the government spent 4 billion, it would have that full impact, be 4 billion times our multiplier. But when we use taxes, it's going to be a diminished amount that's actually spent because we save a portion of it on the front end, right? So if my multiplier is 4, as I can find out because my MPC is 0.75, which means MPS is 0.25, 1 over 0.25 is 4. And then a $3 billion or $4 billion decrease in taxes is going to have a $12 billion increase in GDP. Okay, now how do you calculate the simple tax multiplier? Well, you could use a spending multiplier like I just said. Figure out how much you spend, how much you save, but that takes additional steps. An easier way to do this is to simply do MPC over MPS, right? So if my marginal propensity to consume is 0.75, my marginal propensity to save must be what? You got it, 0.25. 0.5 divided by 0.25 will kick out a multiplier of 3. Okay? So my tax multiplier, my change in taxes will have a multiplied impact of 3. I don't have to take the savings out that's built into the tax multiplier. Okay, so it's just the number 3. So 100 billion will have a $300 billion impact on our GDP, for example. Okay? Okay. Let's say the MPC is 0.2 because that's what the screen says. Or MPS is 0.2. MPS is 0.2. What's MPC got to be? You got it. 0.8. 0.8 divided by 0.2 gives me a tax multiplier of 4. In other words, if I decrease taxes by 100 billion, it will have a $400 billion impact on GDP. Okay, hopefully you're starting to see how this works. What if my MPC is 0.5? Well, if MPC is 0.5, then MPS must be 0.5, which means my tax multiplier is 1, which means I don't have a multiplied impact at all. If I decrease taxes by 100 billion, it's going to have a $100 billion impact on GDP. Okay? So that's how it works. That's the tax multiplier. Not so bad. Plug those numbers in. But I actually have a shortcut for you that makes it even easier. Friends, the tax multiplier is simply the spending multiplier minus 1. So if my spending multiplier is 5, then my tax multiplier is 4. If my spending multiplier is 10, my tax multiplier is 9. If my spending multiplier is 5, I said that one already, 2, then my tax multiplier is 1. Right? Let's just look at our examples. We said 0.75. If our MPC is 0.75, our MPS is 0.25. 1 over 0.25 equals 4. My spending multiplier is 4. But my tax multiplier, we just did this one, it's 0.75 divided by 0.25. My tax multiplier is 3. So it's as simple as that. Memorize how to calculate the spending multiplier and then subtract 1 if you're dealing with taxes and not government spending. Okay, hopefully that makes some sense. Dollars and cents. Why aren't you moving on? Okay, there we go, there we go. So how are these tax changes multiplied? Simply initial change in taxes times our tax multiplier. Remember, this is the reverse. Well, I don't know what happened there. But if I want to stimulate the economy, if I want to increase GDP, I have to decrease taxes. That puts more money in people's pockets. If I want to decrease GDP, I want to contract the economy, then I have to increase taxes. It is the reverse here. But then I just plug in the tax multiplier. So for example, the way I like to do it is I just make the tax multiplier negative. It always kicks out the right number for me. So let's say I decrease taxes by $100 billion. My net tax multiplier is 3. Then my change in GDP is going to be $300 billion. It decreased taxes, so it has a positive impact of $300 billion on GDP. Again, just for my sake, because I'm an idiot and I can't do this conversion in my head, I'll make a dumb mistake. Whenever I put the tax multiplier in, I pop a negative on that. But be careful, that's not actually a tax multiplier. My tax multiplier isn't -3. My tax multiplier is 3. This is just a little shortcut to make sure you're kicking out the right answer. Okay? Just remember the reverse. If I want to decrease GDP, I increase taxes. If I want to increase GDP, I decrease taxes when you're calculating these things out. That's it. Hopefully that made some sense for you guys. 3.2 is available for you right now. Go ahead and take that 4 questions long, and I will see you tomorrow to emphasize this a little bit more. Peace.